Okay, welcome. Today we're looking at fun question here, mainly dealing with right triangles and kind of using some of our skills with trig and then using some Pythag on the back end. And we actually have another question where we use Pythag on the front end and then use some trig otherwise. Now you could answer this question all with trig, but I want to show a question in which you're going to use some trig and some Pythag. So in order to use Pythagorean theorem here, you're going to have to know the distance of basically this side here. Now one way to find this side is to find its difference with the whole length here. So let's call this W, finding this side here. Now one way I could do that is looking at this triangle as 57 with an opposite and an adjacent. Now if I have opposite and adjacent, well, I know that's a tangent with a degree, acute angle degree of 57 with 10 over x. Now I've shown you in other videos, but I can just briefly go over again. If I'm going to get x by itself, I'm going to multiply both sides by x and then end up dividing by 10. And what ends up happening is these two pieces actually end up making a switch. So anytime you have an x on the bottom, just simply switch these two pieces and you'll get 10 divided by 10, 57. Putting this on your calculator is relatively easy. That's just simply finding your tan button or dividing by your tan. Oop, forgot to put division there. 10, 57. And you'll get what we're going to do here is we're going to approximate this at 6.5. Now, that means this piece here is 6.5. So now that I want to know this piece, it's just simply 27 minus the 6.5. I don't know if I necessarily need to use a calculator to do that. But that tells me that this is 20.5. And as you begin to work with Pythag, you'll realize that your x squared is equal to your a squared plus b squared. This is your a and this is your b here. We're looking at this triangle now, just like this, right, with a side of 20.5 and a side of 10. So I have a side of 20.5 squared plus, actually this is a little bit, I'm fast forwarding a little bit. We're going to get rid of this square here. I'm going to show you why in a second. And then you have your 10 squared. Basically how I got that, as a little side note, you have a squared is equal to, no you don't. You have c squared, which is equal to a squared plus b squared. Now if I want to know what the hypotenuse is, I could just take the square root of these two pieces. So you end up with square root of a squared plus b squared. Same thing happens here. I kind of just fast forward a little bit and went from this step to this step here, saying, okay, I know that if I take the square root of both of my legs squared, I'll get my hypotenuse. It makes it easier when you're working in a calculator. It takes out some steps. So I just take the square root of my 20.5 squared plus my 10 squared, and I could just, with one calculation on my calculator, get an answer of about 22.8. And that would be the result of this here. And it makes sense because this is the biggest distance or longest distance, biggest side, which needs to be, your biggest side needs to be opposite your right angle. And here this is 20.5 and here this is 10. So it does fit in this sense. Now this is one where you use trig as a way to get information and use Pythag. This next question, you're going to use some Pythag. So here you have a triangle, a right triangle given two sides. Anytime you're given a right triangle with two sides, you could always find the third using Pythag. Now like I showed you, c squared is equal to a squared plus b squared. Now here they give me a c and a b. So if I want to solve for my a squared, I could simply just subtract b squared from both sides. I get a squared is equal to c squared minus b squared. And now, in order to get this by, I'm going to take the square root. A is equal to the square root of the hypotenuse minus one of the legs. Now let me put that in here and simply say a is equal to my c squared, which is my hypotenuse, minus my leg squared. Again, makes it easier for when we're calculating square root 21 squared minus 10 squared, 18.4. Let's call it 18.5. We are rounding up here. If you want to be more accurate, use more decimal places if that's what the answer choices are calling for. Now that tells me that this here is 18.5. Now that gives me a triangle here, a right triangle here. Let me get a different color going. It gives me a right triangle here in which I have one acute angle and I have a side. Now if I have an acute angle and a side, I could set up a ratio of my opposite and my hypotenuse using SOHCAHTOA or a trig. Now in this case they're giving me opposite and hypotenuse, which is my sine. So sine of 52 is equal to a ratio of my opposite over hypotenuse. Now I explained to you before, yeah, you're going to multiply both sides by x and divide by sine, or you could just simply switch these two pieces here and say x is equal to 18.5 over sine 52. 23.4 about, this is the about symbol. It's not exactly equal to. And this will be our answer here. And again, this is sum Pythag given two sides to get one side, and we're using trig and an angle to get the third. And then the one previously was trig 2 Pythag. Remember, math is easy with hard work.